at the very top of this, we're going to go in and we're going to fill some of this information in, so it'll be a lot easier for you once you start going down this these columns. You'll understand what we're talking about. So, and before I do that, Mason, will you give everybody one of these, please? You can just count them and pass them down the row. So the atomic symbol. How in the world are you going to know what the atomic symbol is? Where's that going to come from? Very good. So it's from the P period T period. So that's what that stands for. Periodic table. In the periodic table that's being passed out right now, coming down to you, the golden periodic table, these are the periodic tables that you will get from on every test from here on out. Okay? I'm not going to make you use your eyeballs to look up here on these walls. I'm going to give you that right in front of you. So no tricks, straight up. You'll always have this to be able to use. Okay? Now, the atomic number. What is the atomic number represent? It represents the number of protons, but the atomic number on the periodic table, how can you tell which number it is based on the number in each box? What if is it always the top right-hand corner? Thank you, that was what I was looking for. It's a whole number, okay? What are the other numbers that are on there? Decimals, very good. And what do those decimal numbers represent? The mass. Now, I'm going to go ahead and just show you real quick, because this is the first time you've ever seen this. Just look at iron, smack dab in the middle at the very top row. Iron in the middle top row, number 26. Do you see how in really, really small numbers going down the right-hand side of the box it says 2, 8, 14, and 2? We'll talk about that later. You will probably never, ever, ever use those numbers. Okay, just kind of keep that in mind, so just don't pay any attention to that. So 26 is the atomic number, it says iron, Fe, and then the bottom number is the mass number. Okay? So let's come back up here. The number of protons. How are you going to determine the number of protons? It's the same, I think I heard someone say this, as the what? Very good. It's the same as the atomic number. Okay. The electrons. Write this down first and then we'll discuss it. And this is the most important phrase. If neutral. Now, there's another column up here that you're going to be able to determine if the atom is neutral or not. What column do you think that is? The net charge. So keep that in mind as we go through this. So if it is neutral, what does that mean? What does that mean? There's no charge. But why would there be no charge? Very good. So if it's neutral, that means the electrons is equal to the protons. So real quick, we're not going to talk about a specific number, but in that very first row where we're talking about element B, if the net charge is 0, what does that tell us about our protons and our electrons? They're the exact same. Okay, and we'll talk about what if it's not, because I know you're going to see some of these positives and we'll get a few negatives as well. We'll talk about that in just a second. Okay, we're going to skip neutrons and come back to that in just a second. Now, a little housekeeping tip or issue real quick. Right here, do the word, add the hashtag or pound sign for me. Okay, so mass number. We just took a quiz on that. What is the mass number? Say it again. Very good. It's the protons plus the neutrons. Can you have a half a proton? Can you have half a neutron? So all mass numbers should be what? Whole numbers. Well, when you look at the periodic table, why are all of your mass numbers written in decimal form? It's an average of the masses of the isotopes, which is what we're going to talk about either tomorrow or Wednesday. Okay, so we'll get to that point. So just kind of keep that in mind, is that none of the masses on the periodic table are going to be what you have on this. So the only thing you need this for is the atomic number and the symbol. None of the masses are going to matter on this sheet. Okay, so let's go back to the neutrons. So if I know the mass number is going to be my protons plus my neutrons, then how am I supposed to figure out my neutrons? Very good. It's the mass number minus the number of protons. Okay, so the mass number minus the number of protons will give me my neutrons. We talked about this yesterday as well, or on Friday. Is it, which one's more often? same protons and neutrons or different protons and neutrons? Which one's more common? Different. Okay. So in fact, when you start doing this, you're going to notice that the proton column and the neutron column are different. For most of them, not all, but for most of them, you will notice that correlation. Okay. And then finally, the net charge. Okay. What does the charge depend on? The net charge depends on the electrons. The net charge depends on the electrons. If you change the protons, what do you change? You change the whole thing. You change the element. But if you change the electrons, we call that thing, try it again, an ion. Very good. We call that thing an ion. So here's what we need to know about plus or minus. If it is a positive charge, and this is where it's going to get kind of weird. If it's a positive charge, you have less electrons. Can someone explain to me why that's true? Very good. So, say that a little louder and a little clearer. Because protons are what charge? Positive. Well, if you have more positives, then obviously your charge is positive. Well, what's the alternative or the opposite to this? If it's a negative charge, what do you have? You have more electrons. Remember, because what does the charge depend on? The electrons. Okay? Alright, so let's do 3 examples together and let's see if we can figure all this out. So, first of all, who is element B? Boron. So, find boron. What is boron's atomic number? 5. Very good. So, if his atomic number is 5, what else is also 5? Very good. The number of protons. Okay? Alright, now, so looking at the number of electrons. So, my first question that you must always have to ask yourself, is this atom neutral, and how do you know? Is it neutral? Yes. How do you know it's neutral? Look at its net charge, which is what? So if it's 0, do you agree to have the same number? Okay, so how many electrons do you have then? 5. Very good. All right, well, they've given us our number of neutrons, so let's go ahead and do our mass number. What 2 numbers do you add together to get your mass number? Very good. What is 5 plus 6? 11. Very good. Pretty much straightforward, right? Okay. This really is just like a big puzzle. And it's you figuring out what pieces do you have and how do you figure out the pieces that you're missing. Any questions on the first row? All right, let's move to the next one. So they give us the atomic number, they give us the number of electrons, and the number of neutrons. So we got to figure out what we're missing. Now, since they give you the atomic number, we can automatically determine what else specifically because of the atomic number. What's the atomic number of same as? Protons. Well, how many protons do you have? Very good. Okay. All right, well, who is number 11? Sodium. What's this symbol? Na. Very good. All right, so let's do our mass number because that's going to be really easy. What 2 numbers do you add together? 11 and 11, protons and neutrons, which is how much? 22. Everybody okay with that? And then the last one is the charge. What 2 things do you look at to determine charge? All right. Are they the same? So that means it's not what? It's not neutral. Okay. So what do you have more of? Protons. So is that a positive charge or a negative charge? It's a positive because you have more protons. How many more protons do you have? 1. So your charge is 1 plus. Any questions? What? The next one. So they only give us protons, neutrons, and then the net charge. Okay. So since they give you the number of protons, what else does that give you automatically? Atomic number. So it's going to be number 31. And who is number 31? Gallium. Very good. What's the symbol? Ga. Fantastic. Okay. Let's go ahead and do the mass number because that's a little easier. What 2 values do you add? which is what's your mass number? 68, very good. And then the one that's a little challenging, we need to do our electrons. And this is the part, and I'm telling you now, it's going to be kind of weird, especially once you get to the bottom. So the charge is 3 positive, which means you have 3 more what? You have 3 more protons, but you've got to remember this fact. Can you change the number of protons? No, they have to stay the same as gallium. So since you've got 31 protons and you've got 3 more of them, then how many electrons would that then give you? 28, very good. Any questions on that row? Oh, you with me? All right, so the charge is 3 positive, right? And we're comparing protons versus electrons. So if I've got 3 more positives, that means I have to have 3 more protons than I do electrons. So you have to take away the number of electrons because that's the only number you can go up and down. Exactly. So you have to subtract it. Exactly. Okay. There is one typo on this worksheet, and I need you to do me a favor. The one it's the 1, 2, 3, 4. It's the 5th row down. It has a number 29 in the atomic number. Do me a favor. All the way over there, net charge, make that a 0. That's the only one you couldn't do without that because you got to have the charge or the number of electrons to figure it out. So put a 0 in that one and see if you can go through and do these.